Okay, fine. Numerical solutions of ordinary differential equations. Numerical solutions of ordinary differential equation. Yesterday, we discussed one important method, desolve method. Okay, I gave one lecture through YouTube. You may observe the lecture, then definitely you can find the very, very important method, desolve method. For solving the ordinary differential equation, we will use desolve method in the platform of Matlab. Now, again, we will discuss about the numerical solutions of ordinary differential equation. The background of desolve method is, the background logic of the desolve method is this type of numerical solutions of ordinary differential equation. So with the help of these techniques, we will construct several programs like desolve methods. Now, what is the numerical solution? What are the numerical solutions of ordinary differential equation? First, what is the ordinary differential equation? Suppose dy by dx equals to f of xy. Now, this is the first order ordinary differential equation. This is an equation, it contains ordinary derivatives. That's why this equation is called an ordinary differential equation. And also some initial conditions are given. Suppose y value at x naught equals to y naught is also given. Then this ordinary differential equation with initial condition is called initial value problem. Now we will solve the initial value problem with the help of several numerical methods. We have several methods in our curriculum. One is Taylor series method, and second one is Picard's method, and third one is Eyler's method, and fourth method is modified Eyler's method, and fifth method, RK method, Runge-Kutta method. Okay, so today we will discuss about Eyler's method and modified Eyler's method. If it possible, we will discuss about the RK method also, depending on the time. So what is Eyler's method? Okay, I will explain briefly Eyler's method. Suppose a differential equation is given, nothing but ordinary differential equation, dy by dx equals to f of xy and y of x naught equals to y naught is given. Then what is the Eyler's method? Very simple technique, just directly I will explain the formula. Yn plus 1 equals to yn plus h into f of xn comma yn. So this is very simple method. Yn plus 1 equals to yn plus h into f of xn yn. So with the help of this method, we can find the required values. For example, I will explain one problem which is given in our assignment question number 5. Now see. Okay, I will take the same question. Okay. Now we will solve this problem. How to solve this problem? First, I will explain the analytical method, numerical method. Then we will discuss about our Matlab programming. Both I will explain one by one. So this is our question. Okay. So use Eyler's method. Find y of 0.1, this is today's first question. Eyeless method to find y of 0.1 and y of 0.2, given that dy by dx equals to x cube plus xy square into e power minus x at y of 0 equals to 1. Okay. Now what is the solution? First, what is f of xy? F of xy is nothing but the right side function of this differential equation, x cube plus x into y square e power minus x, and initial approximation, this is x naught, this is called y naught, x naught equals to 0, y naught equals to 1. Now, here we will find y of 0.1 and y of 0.1. Now we will find, with the help of this method, we will find y of 0.1 and also y of 0.2. So y of 0 is given. Y of 0 is given. Now we will find y of 0.1 and also we will find y of 0.2. How to find this value? So if you observe increment here, x naught is 0. Now this is new value. This is called x naught plus h. X naught is 0 and x naught plus h equals to 0.1. Then h equals to 0.1. In the similar way, increment is also 0.1. x1 plus h is nothing but x2. So in this problem, h equals to 0.1. So you may give directly h equals to 0.1 or you can find the value, then no problem. Okay. H equals to 0.1. Now what is our method? First we will find y1 equals to y naught plus h into f of x naught y naught. So y naught is known, y naught equals to 1, h equals to 0.1, f of x naught y naught. So in place of x comma y, replace x by x naught, y by y naught, that is x naught cube plus x naught into y naught square into e power minus x naught. Now substitute x naught value 0 in this expression, you will get y1 value. Y1 is nothing but y of 0.1. y1 is nothing but, I will write here, y1 is nothing but y of x naught plus h. X naught is 0, h is 0.1, then directly you will get y of 0.1. So y of 0.1 is this one. Just substitute all these values. X naught equals to 0. Now this is 0, this is also 0. E power 0 is 1. Directly you will get 1. Very simple. If you put x naught equals to 0, this term is 0, this term is 0, e power 0 is 1. So the total product is 0 plus 1 is 1. So first value is very easy. Easily we can find y equals to 0.1. Y equals to 0.1. Now this is the step 1. This is step 1. Again we will find y of 0.2. Again we will find 0.2. Step 2. Second question, nothing but second question. Now x1. x1 is nothing but x naught plus h. X naught plus h. X naught is already 0, known, h is 0.1. So x1 equals to 0.1. y1 is nothing but this one, already known, equals to 1. Okay. Now we will find y2 value. y2 equals to y1 using the formula h into f of x1 y1. y1 plus h is already known, h is 0.1, h is also 0.1 into our function is same function x cube plus xy square, x cube, that is x1 cube plus x1 into y1 square into e power minus x1. Okay. Now using calculator, now substitute the value. Y1 is 1, 1 plus 0.1 into x1 value is 0.1 whole cube plus 0.1 into y1 value is 1 square, okay, into e power minus 0.1. Now using calculator, okay, I will open the calculator. I will calculate the value 1 plus 0.1 into 0.1 whole cube, 0.1 whole cube plus 0.1 closing bracket, then e power, e means nothing but shift ln, e power 0.1 with the negative sign, sorry, minus 0.1. So calculate the value, just you can observe it, whether it is correct or wrong. Okay, correct. Now the value is 1.0091. So this is nothing but y2 is nothing but y of 0.2. This method is very easy. I think this is an assignment question which is given in our assignment 3 and also most important for final examination also. Okay. So very easy question. So now how to develop a program, Matlab program for solving this problem. So try to understand, very easy. Okay. So in this problem, first give some function and also x naught, y naught and h, and give the value and substitute the values directly, you will get the value. Again repeat the same process for x1 and y1. For this purpose we will use for loop for 2 or 3 times. Okay, I will show you in our MATLAB software. I will explain in our MATLAB software. Okay. Okay. Up to this, any doubt? Up to this, any doubt? Are you following my lecture?
No, sir. Yes, sir.
Okay, okay, fine. Now, how to write the program? Very easy. Just I will compare both the methods. First, give input of y. So I will give inline function. Okay, I will give inline function. I will type the script file. A script file for Euler's method. Now first ask the function, inline function f. Okay. So first, before that, clear all the variables and clear the our command window. Now f equals to, now our function is a function of 2 variables. Earlier it is a function of 1 variable. Now it is a function of 2 variables. That's why give in different mode. F equals to, okay, I will call it as f, then no problem, x, y. Just only for understanding, I will write xy equals to inline function. Okay, so write at the rate. First I will write in a simple problem, then we will replace this function by input function. Okay, x comma y. Okay, now write the equation. What is the equation? X cube plus xy square, x cube plus xy square, x cube plus xy square. Okay, between these two, multiplication into exp whole power minus x. Okay, exp. Okay, I will check the question. X cube plus xy square into e power minus x. Okay. Now, after giving what are the initial conditions? Okay. So, semicolon, x value, I will write input function, enter the initial value of x. Okay. Later I will replace all these things. Okay, yeah, and also I will use /n. Okay. Now y value in the same way, initial value of y. Now y equals to this one, initial value of y. Now what is the next one? Next value is h. Now give the h value. Okay, this is single quotes, not double quote. H value. Okay, I will write semicolon at the end. H value. H step length. Step length. Okay. So now very important point, just observe. So here h is 0.1, we are starting from 0. We have to find two more times 0.1 and 0.2. So for this purpose, we will apply for loop. So first find out the n value. N value is, okay, I will write n value. So, and also ask the unknown quantity. Unknown quantity, I will take some name. Xn, just I will call it as Xn. Input the unknown quantity or final value, unknown quantity. Unknown value of x. So in this situation, give 0.1, not 0.1, 0.2, directly give 0.2. Initial value is 0, final value is 0.2, step size is 0.1, then n becomes 2. So for this purpose, I will write a small logic for finding n value. N equals to xn. Xn is the final value and x is the initial value, okay, divided by h. So in this situation, we will find the number of times you have to generate our program. So in this particular given problem, we have to repeat the same problem for 2 times for step 1 and also step 2. For this purpose, find out the n value. N equals to xn minus x. X is the initial value, h is the step length. Then finally, you will get the required quantities. Okay. Now after that, we will calculate this value for 2 times. Okay. For this purpose, we will use for loop for I equals to 1 to m. Suppose if you want to find up to 0.0 up to 1, so we have to repeat the same process for 10 times. So with the help of our programming, easily we can find y of 0.1, y of 0.2, y of 0.3, and etc. up to y of 0.1 with step length 0.1. For this purpose, we are using for loop for I equals to 1 to n. Initially, I value is 1 up to I equals to n. N is in this situation particularly 2. Now I will close the for loop just for safety purpose. First, before that, now write the program. What is the program? Why? So use the formula directly. Y equals to y plus h into, so our function is xy of x comma y. Okay. Now observe this one. So very simple program. Here we are using, y equals to y naught plus h into f of x comma y naught. In place of x naught, y naught, we are assumed x comma y. After finding this value, and it is stored in y. Now what about the new value after finding this value? After finding this value, just print fprintf the value of y, okay, write in brackets, okay, fine, percentile f, okay, I will write 0.1 etc, okay, comma x, I will write equals to symbol also, okay, I will close the single quotes, okay, not double quote, single quote. The value of y at x is nothing but y of 0.1, then write the new value y. Okay. Now, what is the new value? Now x is modified. X equals to x naught plus h. X is modified, x equals to x naught plus h. Now x new value is x naught plus h after finding this value. Now what happened? So this is very simple program. I am using very simple program. First give the inline function, ask the initial value and initial value of y, ask the h value and final value, ask the final value, then find the n value. N is nothing but number of times we have to generate our program, nothing but n. So repeat the same process for two or three times depending on the n value. For I equals to 1 to n, find out the y value, y equals to y plus h into, our name of the function is f, or you may use f simply, then no problem, without any confusion. Directly use f, then no problem. So our function is a function of two variables x comma y. So directly substitute x value, y value here. Directly you will get new y value and print y value and print f value. Okay, I will use 4 decimal accuracy. Okay, 10.4. So, but in x value is only 1 decimal accuracy. That's why I will take only one. Okay. Now program is completed. Now save this program. Okay, I will save this program in my drive. Okay, Eyeless. Okay, Eyeless 1. I will call it as Eyeless 1. Okay, now run this program. I will check it if there is any mistake or okay, change the folder. Okay, initial value in this particular problem, initial value is 0. I will give 0. Okay, then initial value of y, that value is 1 is given. Just step length 0.1. Okay, unknown value, last value 0.2. Right here, a small problem here. Wait. Okay, don't use 10. 10 is very large. No need. 10 is very large. And also use /n. Okay. Program is correct. Don't worry. Just rewriting the terms. So x value is 0. Y value is 1. And step length is 0.1. And unknown value, last unknown value is 0.2. Now directly you will get y of 0. Wait. So, sorry, write one more. Wait. This is not x, x naught plus h. This is x naught plus h. That's why typing is 0. Actually 0.1, not 0.0. Okay, I will repeat again. 0, 1, step length is 0.1, final value is 0.2. Okay, now directly you will get the required values. Already known values. Y of 0.1 is 1 and y of 0.2 is 1.0091. Directly we got the values. Are you understand this program? Very easy program, very easy program. Now replace this function by input function, then directly we can give the value. Okay, I will cut it. Okay. Input, enter, okay, wait. Enter the function at the rate x comma y at the rate x comma y. Okay, I will write the equation just only for understanding. So like this, enter the question. Okay, fine. Same procedure. Okay, I will run the program. So before typing this one, okay, I will write the program. Okay, I will write the equation. Okay, then initial value is 0, final value y value is 1, step length is 0.1, final value is 0.6. Now I will change the value 0.6. We can repeat the same procedure for 6 times up to we can find 0.5 also. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Easily we can find the value. Or understand? Any doubts? From student side, there is no response. Yama Jyotika?
Yes, sir.
Advaina?
అర్థమైంది సార్.
ఈజీ అయినా ప్రోగ్రాము? నేను కొద్దిగా
Yes.
టెర్మినాలజీలు అటు ఇటు మార్చాను, నాకు వీలుగా మార్చాను. అప్పుడు ఇచ్చిన కాకుండా రికార్డులో ఉన్నట్టు కాకుండా కొంచెం మార్చుకున్నాను టెర్మినాలజీస్ ఆర్ చేంజ్డ్, డోంట్ వరీ. Suppose if you want to type in a tabular form, write in tabular form methodology, then no problem. Okay. So this is very easy method. Now coming to modified Eyeless method. So same procedure in the similar way, we will discuss about modified Eyeless method. So modified Eyeless method problem. Okay, no problem. So in our assignment question, I will give you a few instructions. So the first question is numerical integration problem. Just find integral 0 to 60. Here tabular values are directly given. You may apply any one of the methods, Simpson's rule or trapezoidal rule or any method. Directly find the integral value. This is RK method and numerical differentiation, and also Picard's method, and Eyeless method is already completed. Trapezoidal rule is, yesterday we discussed about the trapezoidal rule. Okay. Now we will discuss about modified Eyeless method. Okay, what is the method? Okay. Now this is the method. What is the method? Just try to understand. Very simple method, very easy method. Okay, I will copy all these things in our notes, today's notes. Modified Eyeless method. What is modified Eyeless method? Very easy. Easily we can apply our modified Eyeless method. Suppose a differential equation is given like this one, dy by dx, like our Eyeless method. But actually Eyeless method is not a good method. We will get more error with the actual value. For this purpose, we will modify our Eyeless method. Now I am not explaining the derivation of modified Eyeless method. Just I will explain how to apply modified Eyeless method. So same procedure, initial value condition, initial value problem. Now first find y1. This is nothing but Eyeless method. Just completed the method. After finding the Eyeless method, now modify using iterative method. So these three steps are iterative steps like Newton-Raphson and iterative methods. So what is the method? So first we will find the approximate value of y1. Then we will modify it using iterative method, successive approximation method. Using successive approximation, we will modify our y1 value. After that, we will find, after modifying all these things, we will find y2 using Eyeless method, and again we will modify all these things. Okay. So how to modify this one? Now the f of xy is nothing but slope of the curve. Okay. Now I am not explaining. So now we are modifying the slopes. Okay. What is the method? Y1 equals to y0 plus h by 2 into f of x naught y naught, okay, fine, plus f of x comma y1. So now this is first initial approximation. This is called first approximation of y. Now after finding the y1 value using Eyeless method, now substitute here, then y2 is, y1's in second approximation is same methodology, h by 2, f of x naught y naught plus f of x comma, in place of y, write the previous value. In a similar way, y2 is a third approximation of 3. Now substitute this y1 second approximation value in this one and next and so on. If two conjugative values of y values are repeated, then stop the procedure. Then finally you will get y1 value. y1 of nothing, y1 is nothing but y of x naught plus h. This is nothing but y1 value. In the similar way, with the help of this one, again find the y2 value, again find the y3 value, and so on. Okay, I will explain with one important problem. Okay. This problem. This is also our assignment question. Indirectly, I am explaining all the assignment questions. Okay. Now this is today's second question. Now try to understand. First we will find y of 0.3, later y of 0.6. So now in step 1, we will find y of 0.2. In step 2, we will find y of 0.2, y of 0.6. Now observe solution. What is the methodology? First, f of xy. What is the function? So right side function, dy by dx equals to x square minus y square. Our function is x square minus y square. Now what is the initial approximation? Like our Eyeless method, initial approximation is 0. X is 0, y naught equals to 1. H, increment. Here y of 0 is given. We have to find y of 0.3 and also y of 0.6. We have to find this value and also this value. Now observe the increment is 0.3, here also 0.3. So h equals to 0.3. H is 0.3. First, this is entirely step 1. Okay. First, we will apply Eyeless method. First, we will apply Eyeless method, then we will modify it. What is Eyeless method? Eyeless method, just we discussed the method. y1 equals to y naught plus h into f of x naught y naught. Y naught plus h into f of x naught. X naught y naught is nothing but x naught square minus y naught square. X naught equals to 1 plus h equals to 0.3. X naught square is 0 minus 1. So 1 minus 0.3 is 0.7. Now this is the initial approximation for modified Eyeless method. This is the initial approximation of modified Eyeless method. Now we will apply modified Eyeless method. Modified Eyeless method. What is modified Eyeless method? First approximation. First approximation is, okay, now observe the formula. Y naught plus h by 2 into, first value is same as f of x naught y naught, okay, f of x naught y naught plus f of x1, now this is new value x1, and y1 initial approximation, okay, nothing but 0.7. Y naught plus, okay, first I will substitute the function, then we will substitute the values. Y naught square, x square minus y square is our function, x1 square minus y1 square, y1 whole square. Okay. Now what is x1? Here x1 equals to, x1 is x naught plus h. X naught is 0 and h is 0.3. So x naught equals to 0.3. Now substitute all these values. Y naught value is given. Y naught equals to 1. Okay. 1 plus 0.3 by 2. X naught value is 0 minus y naught value is 1 plus x1 value is 0.3. 3 square. Y1 initial approximation of y1 is 0.7 whole square. 0.7 whole square. Just find the value using calculator. 1 plus 0.3 by 2. Now this is minus 1 plus 0.3 square minus 0.7 square. Okay, close the bracket and find out the value. Okay, 79 by 100. Okay, I will find the value.
0.79.
Okay, wait. Fine. 0. Okay, fine.
79.
0.79. This is the first initial approximation. Okay, I will use 0. Okay, I will change the mode. I will change the mode 1. Okay, now. Shift mode 2. Okay. Then no problem. Next time we will get the decimal points. And also fix 4 decimal points. Fix 4 decimal points. Okay, next time we will get the 4 decimal points directly. Now this is the first approximation. This is first approximation. Now second approximation, y1 second value. So y naught plus h by 2 into function is f of x naught y naught plus f of x1 y1, first approximation value. So same formula we are using for second approximation, same formula. So modification is only one term, last term is our modified value. Okay, I will erase this one, unnecessary part. Okay. Now substitute the value, second approximation value, y naught plus h 0.3 by 2, x naught square minus y naught square plus x1 square minus first approximation square. Y naught is 1 plus 0.3 by 2, x naught is 0, y naught is 1 plus x1 is 0.3 square, y1 is 0.7900 whole square, and find out the value. You will get some value. Okay. So 1 plus 0.3 by 2 minus 1 plus 0.3, sorry, plus 0.3 square minus 0.79 square, close the bracket. You will get the required solution. Okay, just find out the value 0.7699 like that. Okay, just check it whether it is correct or wrong, but no problem. This is the methodology. Now same.
Sir, 0.76.
Okay, then no problem. Repeat the same procedure for if x1, x2, two values are repeated. Okay, for this purpose, I will use equation in our formula. In our, I will use a formula in our method. Okay, I will write shift L, alpha ln y equals to, I will use the formula. Okay, no. So alpha cal c equals to y naught is already, y naught is fixed for each and every one, plus 1 plus h is also fixed, h by 2. Okay. Now x naught is also fixed, no need to write, then minus 1 plus x1 is also fixed, 0.3 square minus alpha y square, just only one change here, y only, repeatedly we are substituting. Now cal c. So first approximation, for first approximation y is 0.7. Okay, now press equals to button, you will get first approximation 0.7900, again equals to 0.7699. Now second approximation value, again repeat the same procedure. Now 0.7746. Now next again repeat the same procedure, 0.7735, and repeat the same procedure, 0.7738, 0.7737. Okay, again finally after 4 or 5 iterations, y1 becomes y1, after 4th or 5th iteration 0.7737. So this value is called 0.7737. This is nothing but y of 0.3. This is step 1. In the same procedure, repeat the same process for finding the second value y of 0.6. It will take more time. You may use this equation, the equation in our calculator, then it is very easy. Then it is very easy. Just directly you can type the equation and press cal c repeatedly. Directly you will get the iterative values 1, 2, 3, 4, and etc. If y is repeated, then stop the procedure. Okay, this is very easiest method, modified Eyeless method. In our earlier class, we discussed about arcane method. Today we discussed about Eyeless and modified Eyeless method. Now I will explain Matlab programming for Eyeless method. Modified Eyeless method is also similar method. Just I will copy all these things. Okay, this is modified Eyeless method. Modified Eyeless method. So first, clear all, CLC, f is the input function, x is the input value, y is the output value. Okay, initial value of y, h is the step length, and xn is the final value, n equals to this value. Okay. Now, observe, very, very important. Now we will repeat the same process for number of times, n times. For this purpose, xn equals to n equals to xn minus x by h. Now for loop is 1 to n, same procedure. Okay, I will write some step. This is Eyeless method. Eyeless method. Okay, comment line. This is comment line. Eyeless method. After finding the Eyeless method, okay, I will call it as x1. Okay. x1 equals to x0 plus h. Okay, fine. Now, this is after finding the eyeless method, like this problem, like observe this one. Try to understand, very simple. First, eyeless method. Now, this is the initial approximation for modified eyeless method. For modified eyeless method, initial approximation, okay, I will take the initial approximation, okay. Y is the initial approximation. Now we will apply this modified eyeless method. Okay, I will write here modified eyeless method. Okay. Then how to modify? Very easy. What is the procedure? Now this is modified Eyeless method. So again, we will repeat for number of times. For this purpose, we will use for j equals to 1 to. Okay, I will use while loop. I think better while loop. While okay, after that I will write the some condition, and I will use while loop. Okay, I will write the condition later. Now, what is the inside mechanism? What is the inside mechanism? We will find y1 value, y2 value, y3 value recursively. For this purpose, just we will write this one. Okay. This value is divided by 2. Okay, find h by 2. Just for understanding, directly write in the same place. Now, bracket plus f of. So now try to understand, this is a very, very important point. I will write y1. I will write y1. y1 is the new value, y is the old value. For this purpose, I will write x1 comma y1. I will write x1 and y1. Okay, fine. Now, after finding this value, okay, what is the methodology here? Y equals to h by 2, this one. So after finding the y value, again, this is called a new y value, y1. I will call it as y1. So repeat the same procedure. Now, before that, okay, I will write y1 new, y1 old equals to y1. Okay. So I will call it as y1 old for applying the while loop for conditional checking. Okay. So after finding this is y1 value. Okay. I will write the condition abs of y1 old. I will repeat again, don't worry, just I will explain. Y1 old minus y1, okay, is less than, okay, absolute value less than or equals to 0.0001. Okay, then stop the procedure. If it is true, then only it runs the program. Okay, greater than 1. So I will take, if it is greater than 1, okay, if it is greater than, then the loop will run recursively. So for this purpose, x1 by old value is not given. Okay, fine. Co-initialization of y1 value. Okay, I will give y1 value is big number. Just for understanding, I will give the big number. So y1 old value is a big number. Initially, I am giving big number. So difference is greater than this one, then it will run again and again and again. Then after that, what happened? Now listen, I will repeat again. Very simple. Now I will repeat again, just very easy program. Okay, now I am using while loop, or you may use for loop, then no problem. I think for loop is given in our program. Okay, if condition is also given instead of if and this one. So here 30 iterations are given in our record, but I am totally changed using while loop. Okay, what is the program? Just listen, try to understand. F is a input function, X is output function, Y is this one, and H equals to in step length, Xn is the final value. Now just find n value. We will repeat the same procedure for step 1, step 2, step 3, and so on up to n times. So in each step, first we will find the eyeless method, then apply modified eyeless method. Eyeless method is very simple. So x1 here we will find x1 value, x equals to initial approximation, y is in initial value of y, h and y value. So after finding y1 value, so and also x1 is new value, then find. Okay, fine. Now after that just initialization of x old value, we are giving the big number 1000 or 10,000, then no problem. Now we are using while loop, ABS of y1 old value minus y1. This is eyeless value, approximate value is more than 0.001. Okay, I will take 4 decimals or 3 decimal, then no problem. Then it will, the while loop will run several times until this value is reached. After what is the while inside loop, y1 old equals to, now y1 old is modified, y1 value is stored in y1 old value. Now we will find the new y1 value using modified eyeless method. X, h are the old values in initial approximation. X1 is the modified value, y1 is this value. If y1 is repeated, then stop the procedure. After that, for repeatedly applying the for loop, outer for loop, now we will give x. Now I will give x value after while loop. Now x equals to x1 and y equals to y1. So x now after finding x1, y1, now these are all our required values of input of this again eyeless method. X1 equals to this one. Now we will print the values one by one. Okay, I will print the values after finding the, okay, this is printed. Now first approximation and the second approximation, etc. So the value of y at 0, the first approximation, the first means I will take percentile d, I will give I here, approximation value, okay, I will write this, all these things, okay, fine. So here x1, I will write x1 value, okay, fine. After finding x1 and y1, just type replace it by x and y. I will repeat again, observe. Again, I will explain, don't worry. Modified. Euler or Eyeless. Just 2 minutes. Just I will run this program. Okay. I will run this equation. x square minus y square. Okay, fine. I will run this program. Mute yourself. Mute yourself. Somebody. Initial value. At the rate x comma y, x square minus y square. Okay. Initial value for this problem is 0 at 1. Okay, x naught is 0, y naught is 1, step length is 0.3. Am I correct? 0.3 is the step length. Okay, fine. Now, unknown value, last unknown value is 0.6. Okay, fine. Now, first approximation, second approximation, third approximation. Now, wait. A small mistake, not I, this is J. We are giving index, here index is not given. Okay, fine. Then no problem. J equals to 0, I will give J. I will write J value. J equals to J plus 1. Okay. Not I value. Okay, fine. Initial value is 0. Final value, x by y value is 1. Okay, step length is 0.3. And unknown value 0.6. Someone. Kavya is not following my class. Now observe somewhere, I think, okay. This is first approximation. Okay. I will repeat again. Somewhere it is, indexing is different. Okay, answer is correct. Answer is correct. Final value, okay. This is J. Now observe. Very easy. The given function, initial value of x, initial value of y, step size is 0.3 and unknown value 0.6. So we will repeat the same step for 2 times. Okay. So now first we are giving all the values. Now this is the initial y value, first approximation, second approximation, third approximation. So finally you will get this value. Okay, I think there's a small error in this one. Okay, don't worry. Now this is the Eyeless method. Using Eyeless method, the initial approximation is this one. Okay, now it is correct. Okay, and also first approximation for at 0.6 second and so on. Okay, I will change small y value here. Semicolon is not given. Okay, I will repeat again. Output. Now it is correct, no doubt. Initial value 0, final value 1, step size is 0.3, and enter the unknown quantity 0.6. We will repeat the same procedure for 2 times. Okay, we got the value. So this is one is the value using Eyeless method, and then modified Eyeless method. Okay, we suppose if you want to type all these things, then we can easily find out. These are all modified Eyeless method, like y of 0.1. Already we discussed all these things. Y of 0.1, y of 0. First approximation value, second approximation, third, fourth, all these values. Okay. So in 6th approximation, y value is repeated. Already we find all the values using calculator with the help of Matlab. Already now it is we got the same value. Then repeat the same step for second step, same procedure for finding y of 0.6. Yeah, very easy method. Okay, I will explain briefly again from starting to ending. So this is the input function, give the input function. This is the x input value, y input value, h input value, xn value, unknown final value, number of times we have to repeat n value. So in for loop 1 to n, eyeless method. First, this is the eyeless method. Eyeless method is already discussed. I will call it as y1 and this value is x1 after finding the new value. Now modified eyeless value, I will take y1 old is big number, j is iterative number. Now I will use while loop instead of for, then no problem. If you use for loop, you give the maximum iteration number 30 or 40. If you use while loop, you no need to give the maximum iteration numbers. Now j equals to first value. Now this eyeless value is call it as x old value. Then we will modify the y1 value using modified eyeless method. So x is the initial approximation, y is the initial approximation, x1 is the modified value of x, y1 is the modified value using eyeless method. Okay, then print this value at each and every time. After finding repeatedly, after finding this y1 value, if y1 is repeated, then stop the process using while loop. Then after finding the y value, I will call it as y, and x1 is called it as x, for repeating the same process for second step and third step and final step. Okay, this is, I will write one more step here. Using eyeless method. This is your eyeless method. Then I will write display. I will use the display symbol. Okay, display. Just separation of these two. Okay, again I will run the program. I understand the program, very easy program. Now I will run the program. Just observe function. Initial value is 0 is given. You may give any differential equation, not only particular differential equation. And step size is 0.3. Okay, I will fix the step size. Unknown quantity. So now I will give 1.2. 1.2 means you can repeat the same procedure up to 4 times. Now observe. Now this is using eyeless method. This is step 1, and it is modified eyeless method. Then second step for eyeless method and modified eyeless method, and eyeless method third step, and repeat modified eyeless value, modified value. Then next step, this one approximation values, and so on. So we can repeat the same procedure for 4 or 5 times easily with the help of our Matlab programming. I think this is very easy programming. Just try it tomorrow.